Today we'll be looking at some selected questions from January 2026, Unit 2. We move to question number 1. It says, which of the statement is correct? Now, statement number D says, option D says, the enthalpy change for the forward reaction is plus 40 kilojoules per mole. Now, the enthalpy change for the forward reaction is clearly minus 40. This cannot be plus 40 because these are the reactants. In the forward reaction, this is the reactant, this is the product. So as we move from the reactant to product, the enthalpy change is negative. So therefore, D, we rule out option D. D can never be the answer. D is the wrong answer. Then it says enthalpy change for the forward reaction is minus 70. For the forward reaction, the enthalpy change is clearly minus 40. So C is also a wrong statement. Option number B says the enthalpy change for the backward reaction is minus 30. The enthalpy change for the backward reaction is not minus 30 for the backward reaction. For the backward reaction, this is the reactant, this is the product. This would be the enthalpy change. The enthalpy change would be plus 40. For the backward reaction, this is the reactant, this is the product. So as we move from reactant to the product, the enthalpy change would be plus 40, right? So B is also the wrong statement. Now let us look at A, which is the answer. This is the correct answer. Now for the backward reaction, the activation energy. Now for the backward reaction, this is the reactant and this is the product. So the activation energy is always measured from the reactants to the peak of the activation energy. See, this is the reactant and there's the peak of activation energy. This is the peak of the activation energy. Now the activation energy is always measured from the reactants to the peak of the activation energy. Now if we start from the reactants and if we move to the peak of the activation energy, so this energy change would be 40 and 30 together, which is plus 70, right? From the reactants, if we start from the reactants and go towards the peak, up to the peak, the total energy change is 70. So the answer would be A. All right, clear? Now we move on to question number 5. Which liquids includes hydrogen bonding as one of its intermolecular force? It's very clearly it's ammonia. Because we have studied only molecules that have OH, NH or FH in them have hydrogen bonding. If there is OH, NH and FH in them have hydrogen bonding. So the other compounds, they don't have these bonds. So the other compounds, we rule out the other compounds. Answer should be ammonia. Which liquid would be expected to have the strongest London forces between its molecules? Strongest London forces depends on the number of electrons. Here, if you find the number of electrons, ammonia has how many electrons? Nitrogen has 7 electrons. Hydrogen has 3 electrons, so that would be 10. Hydrogen sulfide, hydrogen has 2 electrons, sulfur has 16 electrons, that would be 18. SiCl for silicon has 14 electrons, hydrogen has 4 electrons, that would be 18 as well. Now let us look at hydrogen bromide. Hydrogen has 1 electron, bromine has 35 electrons. So the total number of electrons is the greatest in hydrogen bromide. So hydrogen bromide will have the strongest London forces between their molecules. So the answer would be B. Then we move to question number C. Which liquid does not contain molecule with a permanent dipole? Now if you look carefully, if you look here, SiH4 is non-polar. Since SiH4 is non-polar, therefore it cannot contain molecules with a permanent dipole, right? See, ammonia is a polar molecule. It will have it will not have molecules with a permanent dipole, right? And no, we should check. No, just a minute. It's not about being non-polar, or is it about having electronegativity difference? I think let us check the data booklet first. Let me find the data booklet. Just a minute. If you look at the Pauling electronegativity index, where's silicon? Okay, silicon and hydrogen. There is a very small electronegativity difference between silicon and hydrogen, although. Okay, so it says which liquid does not contain molecules with a permanent dipole. See, ammonia is a polar molecule. HBr is also a polar molecule. Hydrogen sulfide is also a polar molecule, right? So it says does not contain molecules with a permanent dipole. So it says molecules and not bonds. If the question was about bonds, then we have to check the data booklet and the electronegativity difference. But if it is about a molecule, you have to think about the overall dipole moment of the molecule, whether the overall molecule, whether the overall polarity of the molecule is there or not, whether the overall dipole moment is there or not, right? So it's about overall permanent dipole. Which liquid does not contain molecules with a permanent dipole? Silane does not have a permanent dipole because silane has a tetrahedral shape. Tetrahedral shape molecules are always nonpolar, right? Only if the bonds are identical. Now, since all the bonds are identical here, the SiCH4 molecule will be nonpolar. Okay, we'll move on to the next question. Next question, it says, question number 7. During a redox reaction, what happens to an oxidizing agent? An oxidizing agent will always get reduced and therefore will gain electrons. An oxidizing agent, it oxidizes other substances and gets itself reduced, right? So it would be gaining electrons. Question number 8. Which equation does not represent a disproportionation reaction? If you look at option number A, in option number A, the oxidation number of manganese here is +6, and the oxidation number of manganese in Mn over minus is +7, and MnO2 is +4. See, the oxidation number changes from 6 to 7 and also changes to 4. So it increases from 6 to 7, decreases to 4. So this must be a disproportionation reaction. Therefore, A cannot be the answer. If you look at option number B, the oxidation number of copper here is +1, and the oxidation number of copper here is +2, and the oxidation number of copper here is 0. Now the oxidation number increases from 1 to 2 and also decreases to 0. So B must be a disproportionation reaction. So B is not the answer. If you look at option number C, the oxidation number of iodine is +1, the oxidation number of I- is -1, and oxidation of IO3 minus is +5. Now the oxidation number of iodine decreases from 0 to -1 and increases from +1 to +5. So the answer, so C cannot be the answer, right? Now let us look at option number D. In option number D, the oxidation number of manganese here is +4. The oxidation number of manganese here is +2. The oxidation number of chloride is -1 here, and the oxidation number of chloride here is 0. Now the oxidation number of manganese decreases and the oxidation number of chloride increases. So this must be a redox reaction. So this is not a disproportionation reaction. Okay. Now we move on to question number 9. Question number 9, it says, what is the value of N needed to balance the equation shown? It's very easy. On the left hand side, we have how many electrons here? We have what is the total charge? On the left hand side, the total charge is that's -1, and there are 6 protons, so there's +7. So the total charge, plus 6, that's plus 6, 1 plus 1 into 6, that is plus 6, and that's minus 1. So the total charge on the left hand side is plus 5, right? And the total charge, if you calculate the total charge on the right hand side, the total charge on the right hand side is minus 1. Now what is the difference between plus 5 and minus 1? The difference between plus 5 and minus 1 is 6. So the number of electrons required will be 6. So you calculate the total charge on the left and the total charge on the right. If you calculate the total charge on the left, the total charge is plus 5. If you calculate the total charge on the right, the total charge is minus 1, right? So the difference between plus 5 and minus 1 is 6. So there should be addition of 6 electrons. That's how you figure out this answer. Then we move to question number 10. It says, which change will not increase the rate of the forward reaction? Okay. If you decrease the size of the catalyst, decreasing the size of the catalyst means that you are increasing surface area, which would increase the rate of the reaction. Increasing pressure will increase the rate, increasing temperature will also increase the rate. But if you remove the ammonia, it doesn't increase the rate. This is not a factor that affects the rate of the reaction. Catalyst is a factor that affects the rate of the reaction. Pressure is a factor that affects the rate of the reaction. Temperature is also a factor that affects the rate of the reaction. But removing ammonia, this is not a factor that affects the rate of the reaction. Then we move to question number B. Which of the reactions has the greatest change in the oxidation number of a nitrogen atom? Greatest change in the oxidation number. Okay, let us analyze. Let us look at question option A. In option A, the oxidation number of nitrogen is plus 2 and the nitrogen on the product side is plus 4. So the difference comes out to be 2. Let us look at option B. The oxidation number of nitrogen is plus 4 and the oxidation number of nitrogen here is plus 5. So the difference is only 1, right? The difference is only 1. If you look at option number D, in option number D, the oxidation number of nitrogen is minus 3, oxidation number of nitrogen here is plus 2, and the oxidation number here is 0. So there are two differences here. From 2 to 0, the difference is 2. So the difference here is 2. And from minus 3 to 0, the difference is 3. Now let us look here. The oxidation number of nitrogen here is minus 3 and the oxidation number of nitrogen here is plus 2. Now the difference between minus 3 and plus 2 is 5. From minus 3, if you go to plus 2, from minus 3 going to plus 2, you go to minus 2, minus 1, 0, plus 1 and plus 2. 1, 2, 3, 4, 5. So the change in oxidation number is 5. So the answer would be C. C is the correct answer. Alright. Then we move to question number C. It says, which statement is correct for this particular step? The reaction is carried out at 450 degrees Celsius, blah, 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 blah. Okay. Which statement is correct? At a lower temperature, the yield of sulfur trioxide decreases. That is a wrong statement. The del H is negative for the forward reaction. So a lower temperature will shift the equilibrium to the right. A lower temperature will shift the equilibrium to the right. So the yield should increase, not decrease. So that's wrong. It's a wrong statement. At higher pressure, yield of SO3 decreases. No, at higher pressure, yield of SO3 would increase. Because on the left hand side, you have 3 moles of gases. On the right hand side, you have 2 moles of gases. An increase in pressure will shift the position of equilibrium to the right, increasing the yield of sulfur trioxide. So that is a wrong statement. At lower pressure, cost of reaction vessel increases. How? At lower pressure, the cost of reaction vessel would decrease. The cost would be less. Because you need more energy or you need thicker reaction vessels to maintain higher pressure. Right? So that is a wrong statement. At lower temperature, the catalyst does not work efficiently. That is the only answer that you can write. That because all the other answers are wrong. Okay. So at a lower temperature, the catalyst may not work efficiently. So that is the only answer that you can give, because all the other three options are completely wrong. So this question was designed to find the answer by the method of elimination. You eliminate the other answers. Okay? Now we move to question number 11, which represents the most probable energy of molecules at the lower temperature. Most probable energy of the molecules at lower temperature. See, at lower temperature, peak would be higher and shifted to the left. So this is the curve. This is the curve for the lower temperature. This is the curve for the higher temperature. This is the curve for the lower temperature. Sorry. And that's the curve for higher temperature. The question, it says, most probable energy of the molecules at the lower temperature. It says energy. Energy is found from the x-axis, not the y-axis. We don't give answers A and B because A represents the fraction of molecules, right? It represents the number of molecules, so the fraction of molecules, whereas C and D represents energy. So when they ask about energy, you look at the x-axis and not the y-axis. So the most probable energy of the molecules at the lower temperature. So this is the lower temperature curve. That's the most probable energy. So the energy would be C. So C is the answer. So when you are asked for energy, you look at the x-axis, not the y-axis. Question number 12. Which change would make the solution more purple after the equilibrium has been re-established? A solution would be made more purple. Which one is purple here? Vanadium 2. Oh, vanadium 2 is purple. Okay, vanadium 2 is purple. So the solution would look more purple if the position of equilibrium shifts from right to the left. The solution would look more purple if the position of equilibrium shifts from right to the left. If it shifts from right to the left, it will look more purple. V2 plus will look more purple. So which change would make the solution more purple? Okay, addition of a reagent that removes V3 plus. If the V3 plus is removed, equilibrium will shift to the right. We should shift the position of equilibrium to the left to become more purple, right? Addition of an acid. If you add an acid, the OH minus will be neutralized. So the concentration of OH minus would decrease. Equilibrium will shift from left to the right. Equilibrium would be shifting to the left to the right. So that's also wrong. That's also wrong. A and B are wrong. Allowing hydrogen to escape. If you allow hydrogen to escape, the position of equilibrium will again shift to the right. So the C is also wrong. Increasing the pH of the solution. If you increase the pH of the solution, it means the concentration of OH minus would increase. Increasing the pH means the solution is becoming more and more alkaline. If the solution becomes more and more alkaline, the OH minus concentration increases, so the position of equilibrium will shift from right to the left. If the position of equilibrium shifts from right to the left, the concentration of V2 plus would increase and it would look more purple. So the answer to question number 12 is D. Okay? Question number 13. Which statement about geraniol is not correct? The structure of geraniol is shown. Okay, which statement about geraniol is not correct? Not correct. Okay. It changes dichromate from orange to green. True statement. Because it's a primary alcohol. It would react with the dichromate. Dichromate will get reduced from orange to green, right? It contains 3 CH3 groups and 3 CH2 groups. It has 3 CH2 groups. The 3 CH3 groups. 1, 2, 3. These are CH3. These are CH3 groups. Then CH2. That's 1 CH2, 2 CH2 and 3 CH2. These are the CH2 groups. These 3. And these 3 are the CH3 groups. Okay. So that is the correct statement. It decolonizes a small volume of bromine. Of course, it decolonizes a small volume of bromine because there are double bonds here, double bonds here, double bonds here. It will decolorize a small volume of bromine. It says it exists at 2 pairs of cis-trans isomers. No, it doesn't have cis-trans isomers here. That is a wrong statement. And that is the answer. We don't have any cis-trans isomerism here. Because in order to have cis-trans, you must have identical groups on both the sides. See, this does not have geometric isomerism because they have identical groups here. This double bond here, it has geometric isomerism, but it has easy isomerism. It has easier isomerism. This is an E isomer because the high priority groups on the opposite side. Since the high priority groups on the opposite side, these are E isomers. This is an E isomer. So it can have easier isomerism, but it does not have cis-trans isomerism. Because in cis-trans isomerism, there has to be some common group, right? So this double bonded carbon and this double bonded carbon, they don't have common groups here. They all have different groups here. All the four groups are different. That's one group, that's another group, a hydrogen here, and that's another group here. So when you have four different groups, you cannot have cis-trans isomers. Cis-trans isomers must have at least one common group should be there between the two double bonded carbon atoms, right? So the answer is D because D is the wrong statement here. Because we are looking for the wrong statement. A, B, and C are correct statements. Question number 14. Which functional group may be produced by the oxidation of this compound? If you oxidize, see, it's a primary alcohol. It's a primary alcohol. We have two primary alcohols here, so it can get oxidized to aldehyde. It can also get oxidized to a carboxylic acid because primary aldehydes can get oxidized to a carboxylic acid or an aldehyde depending on the condition involved, because the condition is not mentioned here. So it can either turn into an aldehyde or it can turn into a carboxylic acid. And the other alcohols that you see here, these are secondary alcohols. The oxidation of secondary alcohols will produce a ketone. Oxidation of secondary alcohols will produce a ketone. So the answer will be B, aldehydes, carboxylic acids, and ketones. Alright. Question number 15. It says, what is the best description of the color of the two layers? It said cyclohexane is immiscible with water and less dense than water. Okay. So if cyclohexane is less dense than water, cyclohexane will float over water. Water will be the lower layer, cyclohexane will be the top layer, right? It will be the upper layer. Cyclohexane is added to a separating funnel containing an aqueous solution of iodine. So if you shake with iodine, most of the iodine will dissolve in the cyclohexane layer and it would look purple. The cyclohexane layer would look purple. Now the cyclohexane layer is in the top layer. So we choose purple in the top layer. So there is only one answer, purple in the top layer, right? Because iodine, when dissolved in hexane or cyclohexane or CCl4, looks purple, right? Now since cyclohexane is less denser than water, cyclohexane will float on water. Cyclohexane will be floating on water, will be in the top layer, in the upper layer, and it will look purple. Then we move to question number 16. It says which two spectra are of the same compound. Let us check. It says 2-iodopropane can be converted via propanol to propanol. Okay, 2-iodopropane turned into propanol, okay, and then turned into propanol. Infrared spectra and mass spectra were recorded for each compound for the spectra shown, okay. Were recorded for each compound, okay. Which two spectra? Use your data booklet in making your choice. Okay. All right. Let us check. Let's see. For each compound. Okay. They ask which two spectra are of the same compound. Okay. So this is clearly for the alcohol. The infrared spectra 2. This infrared spectra 2. Let me mark it. Infrared spectra 2 is for propanol. Because we got to know that it's propanol because of the broad absorption here. This broad absorption indicates that it's propanol, right? Now, if you look at the first mass spectrum, it has a relative molecular mass of, I think, 160, was this 160, 160, 162, 163, 160, 162, 160, 161, 162. It is 162.5. This is 162.5. This is the molar mass. So you don't have an alcohol with a molar mass of 162.5, right? So that's wrong. So wrong. It's not actually wrong. It means IR2 and MS1 are not for the same compound, right? Let us compare IR2 and MS2. In MS2, the molar mass found here is 58, right? The molar mass must be 58 because that's 58, right? 58. The molecular peak is 58, so the molar mass is 58. So the alcohol that you get of propan-2-ol has a molar mass of 60. 60, right? Propan-2-ol is CH3, CH2, 43, and 17 is 60. Yeah. So propan-2-ol is 60, right? So therefore, IR2 and MS2 are not for the same compound. Let us compare IR1, infrared spectrum number 1. Infrared spectrum, if we check for propanone, let us check for propanone, okay? If we check for propanone, for propanone, there would be a strong absorption at around 1700. Let us check 1700 here, yeah? That's 1000, 11, 12, 13, 14, 15, 16, 17. That is 1700. This is 1700. Let us look at 1700. If we look at 1700, so this is the spectrum. This should be the spectrum of 2-iodopropane, because propanone must have an absorption for C double bond O at around 1700 per centimeter. But there is no absorption at around 1700 per centimeter. If you look here, there is no absorption at 1700 per centimeter, indicating that this spectrum doesn't belong to propanone. So this particular spectrum belongs to 2-iodopropane, right? Now if you look at 2-iodopropane, and if you compare IR1 and MS2, MS2 has a molar mass of 58 only. So therefore IR1 and MS2 are not for the same compound. But if you find the molar mass of 2-iodopropane has a molar mass of 162.5. And that is why IR1 and MS1 are for the same compound, and that is why A is the correct answer. It's a very different question. This question, previously I haven't seen this type of question in any question paper. It was not a very challenging question, but it was a different question. So we would expect this type of questions in our exam. Okay. So we will be moving on to section B.